All right, today we're going to be looking at discrete math. So we're going to start with permutations and combinations. Permutations and combinations is where you have a certain number of choices and slots. I have 5 people and putting them into 6 chairs, so something along those lines. For permutations, a different order is considered unique. So blue flag on top and red on bottom is different than a red flag on top and blue on bottom. So think like countries with the same colors on their flags, but it's obviously a different country. And for combinations, a different order is considered the same. So if I put an apple and a mango in a blender and drank the juice that came out, there's going to be no difference than if I put a mango in first and then the apple. It's the drink that comes out is going to be identical. So that's the idea between permutation and combinations is do reordered pairs make a different outcome? So for permutations, generally you're going to see this type of notation right here, this NPR. You might also see it like in parentheses. But anyways, N is options, P stands for permutation, and R is the number of slots. So if there are duplicate choices in an equal number of slots, then we can do N factorial, meaning you multiply by every number between that number and 1. So 4 factorial will be 4 times 3 times 2 times 1. And K is the count of each choice. So if we have 3 red choices, 4 blue, and 1 orange, K1 would be 3, K2 would be 4, and K3 would be 1. So that's the idea behind this one, is if you have duplicate choices. If there are no duplicates, then we can do n factorial over n minus r factorial. When we move on to combinations, the only difference in terminology is we have C standing for combinations. If we have no duplicates, then we have n factorial over n minus r factorial r factorial. So note that it's very similar to our permutation formula. Next, there's a specific type of situation where we can use a different formula. So the same number of slots and choices, and any number of choices can be used. So this would be like going to a sandwich shop or anything like that, and they have like on the board that you can order like hundreds of different types of sandwiches, and you're wondering how in the world they even came up with that. This is how. So they use 2 to the n because you can order any thing on your sandwich. Like you could say yes or no to lettuce, you could say yes or no to tomatoes, yes or no to chicken. You can say yes or no to anything. So there's always 2 options for every item available. So that's where that 2 comes from, and then obviously the number of items is n. So 2 to the n. If we have an example, I can go and get I can get up to a 5-topping pizza, and 5 unique toppings are available. How many pizzas can I make? Well, that would be 2 to the 5th power, which is 32. So there's 32 pizzas available at that pizza place with only 5 toppings. Know that there'll probably be some more complex situations than this on the praxis, but these are the foundational principles behind permutations and combinations. You may have to combine them together or add some other statistical idea to it, but these are the only formulas you'll actually be using. For binomial theorem, what this is it's how to simplify a binomial. And it's used in conjunction with Pascal's triangle. So if you have x plus y to the n, then from k equals 0 to n, in the k, then x to the n minus k times y to the k. So if we had 3 up here in this power, and we're just going to leave it as x plus y, it would be, k starts at 0, so x to the 3 minus 0 and would be x to the 3, and then y to the k, which starts at 0, would be just 0. So that would be, it would end up being 1, so it'd be x cubed. And then you'd have plus, and then the next term, x to the 3 minus 1, because we started at k equals 0, and now we're on the second term, so k would be 1, and then y to the 1, and so forth. You would just, as k increases, the power in this term is going to decrease, and so forth. But the leading integer is going to come from Pascal's. So onto Pascal's triangle then. We create this triangle by starting in row 0. So the first row is not row 1, it's row 0, and it's just going to have a 1 there. And for each row after, add the numbers above it. So above this 1 here, there's a nothing, which is a 0, and a 1, so that'll be 1. And that will be the case all across the outside edge. But if we look on the inside, so this term, whatever it is, will be these two terms added together. So 1 plus 1 is 2. For this 3 right here, 1 plus 2 is 3. For this 4, 1 plus 3 is 4, and so forth. And depending on what this power was in the binomial theorem, that's the number that would go in front. So in our case, where we had x plus y to the 3, we would go to row 3, so this is row 0, 1, 2, 3. So when we had x to the 3 minus 0, y to the 0, and we came up with x cubed, we would still have to have the leading integer, which in this case would be a 1. And then for the next term, plus whatever it is, that leading integer of that would be this 3, and so forth until we had our last term. And then next time we'll go over some of the statistics.